A router is a networking device that forwards data packets between computer networks. Routers prefer the traffic with directing functions on the Internet. Data sent through the Internet, such as a web page or email, is in the form of data packets. A packet is typically forwarded from one router to another router to the networks that constitute an internet network until it reaches its destination. A router is connected to two or more data lines from different networks. When a data packet comes in one of the lines, the router reads the network address information in the packet to determine the ultimate destination. Then, using information in Net's routing table or routing policy, it directs the packet to the next network on its journey. The most familiar type of routers are home and small office routers that simply forward IP packets between the home computer and the Internet. An example of a router would be the owner's cable or DSL router, which connects to the Internet through an Internet service provider. More sophisticated routers, such as enterprise routers, connect large business or Internet service provider networks up to the powerful code routers that forward data at high speed along the optical fiber lines of the Internet backbone. Though routers are typically dedicated hardware devices, the software-based routers also exist. When multiple routers are used in interconnected networks, the routers can exchange information about destination addresses using a routing protocol. Each router builds up a routing table listing the preferred routes between any two systems on the interconnected networks. A router has two types of network element components organized onto separate planes. The first one is control panel. A router maintains a routing table that lists which route should be used to forward a data packet and through which physical interface connection. It does this using internal pre-configured directives called static routes, or by learning routes dynamically using a routing protocol. Static and dynamic routes are stored in a routing table. The control plane logic then extracts non-essential directives from the table and builds a forwarding information base to be used by the forwarding plane. The forwarding plane. The router forwards data packets between incoming and outgoing interface connections. It forwards then to the correct type using information that the packet header contains matched to entries in the forwarding information base supplied by the control plane. A router may have interfaces for different types of physical layer connections, such as copper cables, fiber optic, wireless transmission. It can also support different network layer transmission standards. Each network interface is used to enable data packets to be forwarded from one transmission system to another. Routers may also be used to connect two or more logical groups of computer devices known as subnets, each with a different network prefix. Routers may provide connectivity within enterprises, between enterprises and the Internet, or between Internet service providers' networks. The largest routers, such as the Cisco CRS-1 or Juniper PTX, interconnect the various Internet service providers or may be used in large enterprise networks. Smaller routers usually provide connectivity for typical home and office networks. All sizes of routers may be found inside enterprises. The most powerful routers are usually found in Internet service providers, academic and research facilities. Large businesses may also need more powerful routers to cope with ever-increasing demands of Internet data traffic. A hierarchical internetworking model for interconnecting routers in large networks is in common use. Access routers, including small office and home office, denominated SOHO models, are located at home and customer sites, such as branch offices that do not need hierarchical routing on their own. Typically, they are optimized for low cost. Most SOHO routers are capable of running alternative free Linux-based firmware like Tomato, OpenWRT, or WDWRT. In enterprises, a core router may provide a collapsed backbone interconnecting the tier routers from multiple buildings of a campus or large enterprise locations. They tend to optimize for high bandwidth, but lack some of the features of edge routers. Distribution routers aggregate traffic from multiple access routers, either at the same site or to collect the data streams from multiple sites to a major enterprise location. Distribution routers are often responsible for enforcing quality of service across wide area network, so they may have considerable memory installed, multiple wide area network interface connections, and substantial onboard data processing routines. They may also provide connectivity to groups of file servers or other external networks. External networks must be carefully considered as part of the overall security strategy of a local network. A router may include a firewall, virtual private network handling, and other security functions, or these may be handled by separate devices. Many companies produce security-oriented routers, including Cisco PIX series, Cisco Meraki MX series, and Juniper NetScreen. Routers also commonly perform networking address translation. Some experts argue that open-source routers are more secure and reliable than closed-source routers because open-source routers allow mistakes to be quickly found and corrected. Routers are also often distinguished on the basis of the network in which they operate. A router in a local area network of a single organization is called an interior router. An exterior router directs packets between hosts in a LAN, in a local area network, and hosts in another local area network. A router that is operated in the Internet backbone is described as exterior router, while router that connect a local area network with the wide area network are called border routers or gateway routers. Routers intended to internet service provider and major enterprise connectivity usually exchange routing information using the border gateway protocol. An edge router, also called a provider edge router, is placed in the edge of the internet service provider network. The router uses external border gateway protocol in order to work as a part of internet service provider or in a large enterprise or an autonomous system. A subscriber edge router, also called a customer edge router, is located at the edge of the subscriber network. It also uses external border gateway protocol for its providers. Autonomous system is typically used in an enterprise organization. Inter-provider border router is for interconnecting internet service providers. It's a border gateway protocol router that maintains border gateway protocol session with other border gateway protocol routers in the internet service provider autonomous system. A core router resides within autonomous system as a backbone to carry traffic between edge routers. The internet no longer has a clearly identifiable backbone, unlike its predecessor networks. The major internet service provider system routers make up what could be considered to be the current internet backbone core. Internet service provider operate all 4 titles, the border gateway protocol routers described here. They are the core router, internet service provider, and edge router. Internet service provider operate all 4 titles, the border gateway protocol routers described here. Internet service provider operate all 4 titles, the border gateway protocol routers described here. An internet service provider called router is used to interconnect its edge and border routers. Code routers may also have specialized functions in virtual private networks based on a combination of border gateway protocol and multi-protocol level switching protocols. Port forwarding routers are also used for port forwarding between private internet connected servers. Voice, data, fast video processing routers, commonly referred to as access servers or gateways. These devices are used to route and process voice, data, video, and fast traffic on the internet. Since 2005, most long-distance phone call has been processed as internet protocol traffic through a voice gateway. Use of access server type routers expanded with the advent of the internet, first with dial-up access and another resurgence with voice phone service. Large networks commonly use multi-layer switches, with layer number 3 devices being used to simply interconnect multiple subnets within the same security zone, and higher layer switches when filtering, translations, load balancing, or other high-level functions are required, especially between zones. I really appreciate for this time. We are finished so far. We are finished with this chapter, and I see you next time. Thank you very much.